Let's begin with an overview of what a Watch app is and talk about the opportunities available to you as a developer. We'll also talk about the tools you'll use in building your Watch app. You have 3 opportunities to present information on Apple Watch. From the home screen on Apple Watch, the wearer can manually launch your Watch app. The Watch app offers an in-depth user experience and is where you'll focus most of your development efforts. You can optionally provide a glance, which offers the most timely and relevant data from your app in an abbreviated form. You can also provide a custom UI for your app's remote and local notifications. Apple Watch takes advantage of the existing interactive notification support on iOS to allow the wearer to respond with a specific action, transition to a specific area of your Watch app, or later view the notification in Notification Center on Apple Watch. These 3 opportunities are all components of a single Watch app that you deliver within your iOS app. This means that you begin your Watch app development with your existing iOS app, which must support iPhone. In your existing Xcode project, you begin by adding a Watch app target. This target includes all the pieces you need to start building your Watch app. During development, you'll use the same tools you've used in developing your iOS app to create your storyboard and code. Xcode also provides support for viewing, testing, and debugging your Watch app interfaces and code in the iOS simulator. Now that you're familiar with the opportunities and tools used during development, let's look at the architecture so you can see how Apple Watch and iPhone work together to display information to the wearer and respond to user interactions. I've shown you how your Watch app is delivered as part of your existing iOS app. Now let's take a closer look at the core components that make up a Watch app and see how information flows. Your existing iOS app is responsible for installing and managing your Watch app. The Watch app itself is comprised of 2 pieces. The first is the iWatchkit extension. The extension runs on iPhone and executes your code in response to user interactions on Apple Watch. On Apple Watch, your Watch app's UI is loaded from a bundle containing your storyboard and static resources, such as images. Now that we know which components are involved, let's focus on how the Watch app and iWatchkit extension work together to deliver a seamless user experience. When the wearer views your Watch app, glance, or notification, Apple Watch loads the appropriate interface from your storyboard and tells iPhone to run your iWatchkit extension. As the wearer interacts with the Watch app, Apple Watch and iPhone pass information back and forth. Taps and other messages from Apple Watch cause code in your iWatchkit extension to execute. That code is responsible for updating the Watch app UI and performing any necessary tasks related to providing data to your Watch app. To summarize, your storyboard and all of your static resources are stored in the Watch app bundle. The Watch app target provided to you by Xcode already contains the storyboard you'll use during development. Because these resources are part of the Watch app, they must all be specified at design time and can't be added, removed, or changed at runtime. This means you need to incorporate all of the UI elements that you might need into each scene of your storyboard. At runtime, code in your iWatchkit extension can update those UI elements, including hiding or showing them as needed. Additionally, your iWatchkit extension can send dynamically generated content over to the Watch app for display. The way you make these updates is by using the classes of the iWatchkit framework. Let's take a look. The iWatchkit framework provides all the objects to manage your Watch app's UI. This includes controllers, UI elements, and device-specific information. Let's start with controllers. The WK Interface Controller class is the main subclassing point for your WatchKit extension. An interface controller manages the UI elements for a single screen of content. It sets the initial values of those elements, responds to user interactions, and updates the UI as appropriate. When you create your interface controller subclass, you add outlets for each UI element you need to manage. These outlets connect to objects in your storyboard and handle the transfer of information between your WatchKit extension and Watch app. In addition to outlets, you set up action methods for the interactive elements of your storyboard. As with outlets, you connect each action method to the corresponding UI element. When the wearer interacts with that element, WatchKit calls your action method. Now let's look at some of the UI elements that you can arrange in your Watch app's interface. WatchKit provides an assortment of different objects for displaying information and handling user interactions. Most of these objects should already be familiar to you because they are similar to objects you've used in your iOS app. In addition to the usual buttons, images, switches, sliders, and labels, WatchKit provides a few specialized objects for you to use. A separator object provides a visual break between UI elements. Dates and timers are special types of labels that update their values dynamically. A date object displays the current date and/or time formatted to your needs. A timer object counts up or down from a specific NS date in the future or past. Once set, both objects run autonomously in your Watch app and do not require additional intervention from your WatchKit extension. In addition to the basic UI elements, there are some other elements that you should pay special attention to. The first object is a group. Groups are used heavily for laying out UI elements within your interface. Unlike iOS, where you place views at a coordinate on the screen, with WatchKit, objects automatically flow downward from the top left corner of the screen, filling the available space. Groups are a way to manipulate the spacing and arrangement of UI elements to achieve the look you want. Arrangement can be horizontal, placing elements side by side, or vertical, stacking elements on top of each other. Additionally, you can configure margins and inter-item spacing for more precise placement of elements. Groups don't have a visual appearance of their own, but you can add an appearance using a background color or image. And you can nest groups to create sophisticated layouts within your interface. Tables in WatchKit are similar to tables in iOS, and you use them in many of the same situations. A table is a single column of dynamically created rows that you configure programmatically from your interface controller. Tables support multiple types of rows, which you can use to differentiate content rows from rows displaying header and footer content. Configuration of the table differs from iOS in several ways. You define the appearance of each row type in your storyboard. At runtime, you tell WatchKit what types of rows you want and how many of each one you want. WatchKit then creates the rows and provides you with a row controller object to manipulate the contents of each row. Selections in the table are handled by your interface controller. A map object displays a non-interactive version of the standard map interface. The map itself is a snapshot of a coordinate region or map rect that you set programmatically from your WatchKit extension. The snapshot is then rendered on iPhone and sent to your Watch app for display. You can add up to 5 annotations to the map, and those annotations are represented on the map using standard pins or custom images that you provide. If a custom image cannot be found, the system will fall back to a standard red pin. Because the map doesn't pan or zoom, tapping it takes the wearer to the Maps app on Apple Watch. All of the UI elements available in WatchKit have standard configurable properties. Programmatically, you can set height and width to a fixed value. Using Interface Builder, you can set height and width to a fixed value or to a relative value based on available space. As we previously mentioned, you can hide and show elements or change their alpha to affect their appearance on screen. Hiding an element will effectively remove it from the interface and make additional space available for other elements. Setting alpha to 0 makes the element invisible but preserves the space. All UI elements have accessibility support, and text-based elements can be localized. WK Interface Device provides device-specific information with which to configure your watch app. Using the screen bounds property of the shared device object, you can configure UI elements appropriately at runtime. This allows you to optimize your watch app interface for both the 38mm and 42mm Apple Watch display sizes. Using the device's current locale, you can format strings, numbers, and other user-facing content appropriately. If a wearer has set display text to a smaller or larger size than the default, you can use the preferred content size category property to ensure that any text that your watch app is displaying, which may not take advantage of the built-in text styles, is adjusted accordingly. With the knowledge of what the iWatchkit framework provides you, it's time to start building a watch app. In this section, we're going to see how to create your watch app's interface using interface controllers and UI elements in Interface Builder. We'll also take a closer look at creating glances and how to provide a custom UI for your app's notifications. We've looked at the interface controller class, but haven't yet observed its life cycle. It's important to know when an interface controller gets called for setup and teardown so that you're configuring UI elements at the right time, as well as performing cleanup operations or finishing tasks when the wearer stops interacting with your watch app. When your watch app is launched on Apple Watch, the iWatchkit extension is launched on iPhone. Next, the storyboard in your watch app bundle is loaded on Apple Watch and the initial interface controller is created. Once the UI is initialized, your interface controller will receive an init with context call, giving it a chance to initialize variables for state and configure UI elements with their initial values. When the UI of your watch app is in the process of getting displayed on screen, Will Activate will be called, allowing you to perform any last-minute tasks or final UI element configurations. As the wearer interacts with UI elements, iWatchkit calls the action methods that you defined on your interface controller. Those action methods are your chance to execute code and update your app's UI. Keep in mind that engagement times will be short. Finally, Did Deactivate will tell your interface controller when it is no longer on screen, and the iWatchkit extension will soon be suspended. An interface controller can be deallocated any time after the call to its Did Deactivate method returns, so use that method to save app-related state information and close out any ongoing tasks. The watch app target you added to your Xcode project contains an initial interface controller class and a corresponding scene in your storyboard. This interface controller is designated as the main entry point for your watch app. When your watch app is launched from the home screen, this interface controller will be displayed first. Using one interface controller in an app is fine, but most apps have more than one screen of content. To support multiple screens, watch apps can use one of two styles of root-level navigation. The first navigation style is hierarchical, which behaves similarly to UI Navigation Controller on iOS. You start with a single controller and push and pop controllers on and off a navigation stack. The second navigation style is page-based, which behaves similarly to UI Page View Controller on iOS. To create a page-based interface, you link two or more interface controllers together at design time. At runtime, the wearer navigates between controllers by swiping left and right. Glances are a great example of this interface. Because you link the interface controllers at design time, the total number of pages is fixed and cannot be changed later. Be aware that you cannot mix hierarchical and page-based navigation styles in your app. Whichever one you choose becomes the style you must use from then on. A navigation stack cannot push to a page-based interface controller. Equally, a page-based interface controller cannot push new controllers to create a navigation stack. There is one caveat to being tied to a specific navigation style. Any interface controller can present another interface controller modally. A modal interface can contain a single interface controller or a set of interface controllers arranged using a page-based navigation style. Back in Xcode, I've decided to make my watch app use a navigation stack. I'll eventually add an additional interface controller to the storyboard and push a controller onto the navigation stack when a row is selected. But for now, I'm just going to show you how to add a table, position elements within a group, and add data to the table rows. I've added a table to the initial interface controller and connected an outlet to it. The table will display city names nearby and allow the wearer to tap on them to push to a new controller with detailed information. Tables are created with a single row type automatically, and you can see in the Attributes Inspector in the top right that I've set an identifier for the row type so that I can reference it in my controller's code later. I've also set the row controllers class to a new NSObject subclass I've added to my project called City Row Controller. The City Row Controller class doesn't have any special code of its own. Its job is to define the outlets I will use to configure the contents of my rows. In this case, I've connected an outlet to the location label displayed in each table row. To make the rows of the table look nice, I've assigned a background color and spacing to the group object contained in the row controller. This group is also configured to display its items horizontally so that I can then place items side by side. Next, I've added an image to the rows group with a fixed height and width of 40 points. This will display a location marker icon to the left of the label I've added to the row type. To complete the rows UI, I've added a label that is sized to fit its content and vertically centered within the group. Since the image to the left of the label is a fixed width, the width of the label sizes to fit the remaining available space in its container, which is the group of the table row in this case. I've also set the minimum font scale to 1, which will ensure that the text remains the size I want, but will truncate if the label gets too long. Now that my interface is designed, I need to tell the table to create rows for each city. I do this at runtime using a method called loadTableData, which I call from the initWithContext method of my interface controller. LoadTableData takes an array of city names and creates rows for each one of them. I could have retrieved the city names from my iOS app, but here I'm using a static array. I then use the setNumberOfRowsWithRowType method of my table to specify the number of rows I want and the type of each row, which in this case is the default row type I created in Interface Builder. This method creates the rows in the UI and also creates the row controllers I need to configure each row. From there, all I have to do is iterate over the row controllers and set the value of its label to a city name. I'm ready to see my progress, and by clicking on Build and Run in Xcode, with my Watch App Scheme selected, the iOS simulator launches. In the iOS simulator, click on Hardware in the menu bar and choose an Apple Watch option from the External Displays menu. Everything is looking good, but when I tap a table row, nothing happens. So now I need to implement the table didSelectRow@Index method in my interface controller to handle row taps. In that method, I'm going to call pushController with name context to push a new interface controller onto my app's navigation stack. When pushing the interface controller, I'll pass a data object in the context parameter that identifies the selected city. The newly pushed interface controller will use that data object to configure itself and display the city information. An interface controller can display a menu using the force touch gesture. This menu can contain 1 to 4 items, which you then connect to action methods on the interface controller. Each menu item consists of an icon and a label. The icon is an image which is used by the system as a template image. The label can be up to 2 lines long. WatchKit also offers a number of default menu items to use. If you want to display additional information or choices after the wearer taps on a menu item, you should present a modal interface controller to do so. As I previously mentioned, creating a glance is another great opportunity you have on Apple Watch. A glance is an abbreviated version of your app that offers timely and relevant information. Wearers get to their glances by swiping up from the watch face on Apple Watch. Glances are template-based interfaces. You can choose from a variety of label and image arrangements to display your data to the wearer. When the wearer taps on the glance, your watch app is launched. This is a very quick way for the wearer to get into your app and be routed to relevant data. By leveraging handoff, you can deep link to any controller in your watch app when the wearer taps on the glance. Creating a glance is optional, and be aware that the wearer can turn your glance on or off as they choose. Apple Watch takes full advantage of the existing interactive notification support on iOS. Even if you haven't built a watch app yet, wearers can still receive notifications on Apple Watch, letting them stay aware of timely information. Once you have built a watch app, notifications get even better. When a notification is sent to Apple Watch, the wearer will first receive a short look notification. A short look notification includes a discrete and minimal amount of information about the notification. The short look includes your watch app icon, a title that you set in your notification payload, and the name of your app. If the wearer keeps their wrist raised during a short look notification, after a moment, it will turn into a long look notification, which then you can provide a custom UI for. A long look notification displays your app icon and the name of your app in the top banner or sash area. You can configure the color of the sash at design time. You can also place content behind the sash by making the sash translucent. Below the sash, you can provide a completely custom UI to display additional information that may relate to the notification. Notifications can be local or remote, and you can use callbacks in the interface controller subclass to respond to each type. Notification category types are used as the basis to provide a different customized UI per type of notification. This category is passed in the notification payload, and you can set the category on each notification entry point in your storyboard. With each type of custom notification you provide, you'll also need to provide a static version of the UI. This is for situations where notifications may be rate limited or the device may be in a low power setting. In a static notification, you provide generic images and labels that won't require dynamically generated data. Making use of interactive notifications on iOS, Watch App notification payloads can describe specific action buttons to display, which will launch your Watch app and provide a context object so you can direct the wearer where they need to land in your app. Finally, there is support for testing and debugging custom notifications within the iOS simulator. By creating a push notification payload JSON file, you can provide data to display in the simulator so that you can see what your notifications will look like at runtime. Let's conclude this introduction to creating apps for Apple Watch with some advanced tips that may be helpful to be aware of as you begin building Watch apps. The handoff API available in WK Interface Controller is what you use in your glance and notification interfaces to create deep links into your main app. You use this API to package up relevant information about what your interface is currently doing and pass that information to your app's main interface controller, which can use the information to present a different interface upon launch. Additionally, you can use handoff as an excellent way to allow the wearer to move between Apple Watch and iPhone to engage in your app for a longer period of time. Animation on Apple Watch is done using animated image sequences. These are sequentially named image resources that the system loops repeatedly. You can also specify a range of images to animate over a specific duration with a defined repeat count. Images can also be cached on Apple Watch before you may need them using the WK Interface Device class. You can store up to 20 megabytes of image resources in this cache. This is a great way to dynamically generate content and have it available in your Watch app before you actually need it. If you have Watch app settings you would like to make available to wearers, you can use a settings bundle similar to iOS. This settings bundle is exposed in the Apple Watch app on iPhone. You should leverage your existing iOS app for your Watch apps data needs whenever possible. Using app groups and NS user defaults, you can easily share small amounts of data between your iOS app and your WatchKit extension. For access to other resources, such as a core data store, use a shared container between your iOS app and your WatchKit extension. This makes data access simple and gives both your Watch app and iOS app up-to-date information. Finally, if you have code that you would like to share between your iOS app and your WatchKit extension, creating a framework is a great way to do this. It keeps the code accessible and ensures that bug fixes don't have to be duplicated across multiple instances of code in your projects. We've covered what Watch apps are, how they're architected, and what the WatchKit framework provides to help you build apps for Apple Watch. You've seen how easy it is to build your interfaces with Xcode, and you've learned some advanced concepts, including how to leverage code in your iOS app for your Watch app. Be sure to read the WatchKit programming guide and check out the WatchKit framework reference to learn about the nuances of specific WatchKit objects. We're really excited to see what you create for Apple Watch.